Welcome back, dear participants. We are now moving on to the final session of our first day of the two-day international conference. This session is titled Impact of Emerging Technologies on Enhancing Peaceful Uses of Nuclear Technology. It examines the intersection of innovation and peace and explores the transformative potential of emerging technologies to advance nuclear science for the benefits of humanity. The conversation is crucial as it highlights opportunities for sustainable development and security enhancement worldwide. This session features 3 eminent speakers, 2 presenting on-site and 1 contributing virtually. As before, their presentations will be followed by a Q&A session and distribution of shield. We will then conclude the day 1 with a group photograph session. Ladies and gentlemen, this session will be moderated by Dr. Rahat Iqbal. She is Associate Director Research at Center for International Strategic Studies, Islamabad. She holds a PhD in International Relations from the University of Peshawar. She has presented at various national and international platforms, including International Atomic Energy Agency Vienna and Global Peace Summit New York. Her research interests include nuclear safety security, peaceful uses of nuclear technology, arms control, and disarmament. Dr. Rahat, we look forward to your moderation of this session. Over to you.
Thank you, Ms. Anam. Dear esteemed guest, Assalamu alaikum and good afternoon. I warmly welcome you all to this significant session on the impact of emerging technologies in enhancing the peaceful uses of nuclear technology. I am Dr. Rahat Iqbal and I have the privilege to moderate the session. As my colleague has already said that for this session, we are honored to have 3 distinguished speakers, 2 of whom are with us in person, and 1 will be joining us online from Vienna. Ladies and gentlemen, I welcome Mr. Anton V. Chlupkop, the Director, Center for Energy and Security Studies, Dr. Robert B. Hayes, Associate Professor in the Department of Nuclear Engineering at North Carolina State University, and Dr. Tariq Raouf, the former Head of Verification and Security Policy in International Atomic Energy Agency, IAEA, online, who joined us from Vienna. Ladies and gentlemen, the nuclear technology plays a crucial role primarily in energy production, medical, and healthcare. With the help of this technology, the countries can achieve the 11 to 13 Sustainable Development Goals out of 17. While benefiting from this technology, the Pakistan Atomic Energy Commission has established 19 cancer hospitals nationwide. Pakistan is also utilizing the radioisotopes in the field of agriculture. This aims to enhance the productivity of agriculture through new crops, innovative techniques for pest controls, water provision, and nutrition. Hence, keeping in view the significance of nuclear technology for the socio-economic benefits worldwide, this session will focus on the role of emerging technologies in enhancing the peaceful uses of nuclear technology. The esteemed speakers will further amplify the topic. I would like to mention that each speaker will have 20 minutes to present his or her views.
Thank you, Dr. Iqbal. It's a real pleasure to be back to Islamabad, and many thanks to Ambassador Naqvi and CISS for inviting me to speak at this conference. I would like to apologize in advance because I have to leave to the airport right after my presentation, but I would be pleased to catch questions if we will have time, or we'll be in position to respond to the questions online late. Again, I apologize for that tense schedule. It looks like in the current geopolitics, more and more people are interested in the kind of military domain rather than in the civilian domain, and I mean, a number of vacant seats during this session in the conference room probably proved that, my impression that there were much more people who were interested in military applications of nuclear technology, of new technologies, including AI, during the previous sessions. But of course, this is a joke. I will use slides. I just would like to start with a few words to remind about advantages of nuclear energy. First of all, of course, enormous energy density. Then reliability. If you would like to have a data center or steel plant, you need a reliable source, big source of electricity. You cannot rely on wind or on solar. This is where nuclear energy step in and could provide necessary amount of electricity and be quite reliable source of electricity. Of course, it's also about potential role of nuclear energy and nuclear industry to address climate change issues, which all of us face, and a couple of numbers. For example, the nuclear power plants in Europe prevent the emission of 700 million tons of CO2, and in Russia this number about 200 million tons each year. For some countries, the size of the facility which produces electricity could be a big issue. So nuclear power plant has relatively small footprint. Again, for some countries, it has a big importance. For countries like Russia, not so much, but this is an important advantage. And of course, an impact on the economy sector. For example, if a country builds a nuclear power plant abroad, usually dozens, if not hundreds of other local companies are involved to provide services, and it is believed that every job created in the construction of the nuclear power plant, for example, create more than 10 additional jobs in other sectors. Again, this is just to remind some of the advantages of the nuclear industry, nuclear energy. Of course, there are risks associated with the nuclear industry, and we know them well. Where we are today, from the point of view of use of nuclear energy, 31 countries use nuclear power plants for electricity production. More than 400 thank you. Thank you. More than 400 of nuclear power plants are operational globally. But what is even more important for me, that more than 60 nuclear power units are under construction, and number of newcomer states are expected to start operation of the nuclear power plants relatively soon. For example, it is expected that for the next 5 years, Turkey will start operation nuclear power plant, first on its territory, Bangladesh, Egypt about the same time. Within the next 5 to 7 years, Uzbekistan should start operation. It's a nuclear power plant. The construction just recently started. So, and also, if we will have a look on the forecast or predictions, including what is forecasted by IEA, it is expected that within the next 25 years or so, the production of electricity by nuclear power plants could increase in 3 times. Of course, this is predictions. This is about predictions. And some predictions in the past regarding the nuclear power plant did not materialize. But I think there are a number of other indicators and signs that nuclear industry will grow. And of course, for my country, for Russia, nuclear industry is really important one, because nowadays 18% of electricity produced in Russia by nuclear power plants. Russia also the leading nuclear power plant constructor abroad. Nowadays, more than 20 units are being constructed by Russia in 7 countries: Bangladesh, China, Egypt, Hungary, India, Iran, and Turkey. And I already mentioned Uzbekistan. It is planned the construction work will start there this year or early next year. And in Russia itself, there are 4 nuclear power power plant units which are under construction, and the plan to increase the share of electricity produced by nuclear power plants by 40-45 from 80 to 25%. And of course, a big issue both for those countries which develop nuclear energy and nuclear industry, and for Russia as well, how nuclear technologies, I mean, and I would speak even not only on AI, but broader new or emerging technology, including AI, what role they can play, how they can help to develop nuclear industry further. And here I think there are a few dimensions. First of all, we should not forget that nuclear safety is the central issue for the nuclear energy. When we think about nuclear industry or nuclear energy development in a country, nuclear safety is the key criteria or element of those plans. Second, I think in the current circumstances, it's still quite a challenging issue for a number of countries how competitive the nuclear energy is. It depends on the country, and of course the increase of the price for oil and coal, of course, make nuclear industry is more competitive. But we should not not forget that the price for electricity is not the only criteria for a country or an energy company to decide whether to build a power plant which use coal or, for example, solar or wind or nuclear fuel, including for the reason which I mentioned at the beginning, how reliable the source is. I mean, what is the level of support of nuclear energy in this particular place, and there are many other criteria which contribute to decision making what kind of electricity production facility has to be built. I should mention that the integration of emerging or so-called emerging technologies, including AI, in the nuclear industry or nuclear sector has already started, and it's not clear where it will end. As many other sectors and areas, emerging technologies already demonstrated the advantages as well as, of course, risks associated with them, and this is also, of course, an issue for the nuclear energy field. I will speak on that later. Also, there is an important dimension which I will mention but will not cover in any way in my presentation, how new technologies, emerging technologies could help to strengthen, for example, IAEA safeguard system and verification. As I understand, Tariq Raouf will speak in details on this point. I just would like mention that this is quite an important area, and new technologies, emerging technologies bring some additional proliferation challenges, but also some opportunities and some benefits. I would like to mention a few examples which are already available from the nuclear industry where new technologies, including AI, contributed. For example, there is an understanding that NI can help analyze large amounts of data from aerial surveys to find areas rich in minerals like uranium, which is used for the nuclear fuel. Also, if we think about, for example, the centrifuge production, the centrifuges, if the the centrifuge technology, the central technology nowadays to enrich uranium, so there is understanding that AI can help to reduce costs associated with design, testing, and production of centrifuges. It could also save time for developing of new design, more productive, more efficient design of centrifuges. And also, of course, reduce associated expenses. Nuclear power plant design, quite similar situation, that new technologies can help to reduce time which is necessary to design new types of reactors, to test their prototypes, and also, I mean, to better understand what should be the nuclear technologies, including AI, can improve efficiency of nuclear power plants operation and increase their economic competitiveness. Because as I mentioned, for a number of regions, for a number of countries, the issue how competitive the nuclear power plants are is a big one. In the past, we know that some nuclear power plants were closed, for example, in the US for that exact reason. So if new technologies will bring additional opportunities for producers and operators, owners and operators of nuclear power plants to reduce associated costs, again, it could increase the attractiveness of new big scale and of the reactors and SMRs as well, small modular reactors. There are a number of other areas associated with the nuclear sector, with nuclear power plants operation, where new technologies could help. But again, I think what is probably not probably the most important issue is nuclear safety. And here I would like to mention so-called digital twin technology, when a digital twin of a nuclear power reactor could be established, and it could help a lot to forecast the operation of the nuclear power plant and increase the safety of operation. I would not go through all of the points I have on my slides, but just would like to mention those examples. They are just a few how the new emerging technologies are already used by the nuclear industry. Also, a couple of examples from Russia's experience in integration of new emerging technologies, including AI, into the nuclear sector. For example, those technologies are actively used in uranium mining, and there is a particular example. Thank you. There is a particular example when, with assistance with those new technologies, the efficiency of uranium mining at Hyagda facilities was increased. Also, it's about safety of personnel which work at the uranium mining facilities, but it could be also this technology could be also applied to other nuclear-related facilities, of course, in Russia and abroad. And also I would like to mention that the predictive models for generators, turbines, and circulation pumps have been applied at the recently built new nuclear power plants in Russia, including the 6th unit of Voronezhskaya nuclear power plant. It gives operators a better sense what they could expect from the behavior of equipment at this particular facility, according to data available from the Russian State Nuclear Corporation Rosatom. So algorithms are capable of predicting the parameters of a nuclear power unit 30 minutes in advance, which I think very important when we think about the safety of operation of nuclear power plants. I think it is really important when we think about role of emerging technologies and particularly AI in the nuclear industry to be clear that human should continue to be in the center of operation of the nuclear power plant. So human in the loop concept is very much applied to nuclear power plants as well. It has to continue to be the central or critical point for operation of all nuclear power plants. But new technologies could support, could assist operators to increase safety of the facilities, nuclear facilities, including safety of operation of nuclear power plants, and I already made a couple of examples earlier. And what is important here, and I hope that Tariq Rauf will cover this issue as well in his remarks, that IAEA should become a key international platform to develop standards and regulation frameworks for new technologies use, including AI in the nuclear sector. As I understand, IAEA Secretariat already work actively in this field, and I think later this year there would be the second conference on the role of emerging technologies in the nuclear industry, the second conference in Vienna. And I do believe that an international dialogue, inclusive dialogue, where nuclear vendors as well as newcomer states, those which just recently started development of nuclear energy or just interested in this technology, should be involved, should be engaged to discuss the role of regulation of norms in this field. And I think the best platform for that kind of discussion. A couple of final points. There is an irony that, as I mentioned, from one point of view, new technologies are able to support and assist to increase efficiency of nuclear industry, as well as to make it even safer. But at the same time, new technologies require sometimes a lot of electricity. It means that there is an additional demand, including in construction of new power plants or resumption of operation of those which were shut down, including those which were permanently shut down. And here, an example I have in mind, of course, the Three Mile Island, the place where one of the most significant nuclear accident took place in the past. The first unit of the nuclear power plant was permanently shut down in 2019, but nowadays, because of the request from Microsoft, there is a plan to restart operation of this nuclear power plant, the first unit of the Three Mile Island, relatively soon. So I will stop here. And if we have a few minutes, I would be pleased to take questions. Otherwise, as I mentioned, we'll be pleased to respond online. Thank you.
If you have any questions, you can ask him. We'll just only take 2 questions, keeping in view the sensitivity of his flight to Vienna. Thank you.
Thank you. Thank you for very informative discussion. My question is about vigilance, how AI can play a role in vigilance of nuclear security personnel.
Could you repeat it, please?
How AI can play a role in vigilance of nuclear security personnel, how it can increase their vigilance.
Well, I think AI could have both a positive and negative impact, because we know well that sometimes nuclear scientists were targeted in some countries, and AI was used for that, by the way. This is about not security, but unsecurity. But with regard to security, I already made one of the examples how the new technologies were used for nuclear safety. For nuclear security, well, to prevent illegal transportation of the nuclear materials, nuclear technologies. Again, I don't have a particular technology in mind how it would be applied, but I would imagine that those companies which are involved in the nuclear security business, which provide their services, will be very much interested to integrate this technology, AI, other emerging technologies in the products which they offer on the market. Probably my colleagues who will speak on that panel, Rob and Tariq, will provide some examples which they are aware of how AI could use and what are the examples available today where AI could increase nuclear security.
Yes, please. Next question.
Thank you, Dr. Anton. As Dr. Bilal Zubair, Director Research, CISS. A very, I would say, useful presentation, very important presentation. And one particular point that you highlighted regarding the IAEA providing some sort of platform for the artificial intelligence for peaceful purposes and a broad acceptance by the member states that IAEA can provide such a framework. Can we envisage in the future that such guiding platform or principles can also be applied in non-peaceful nuclear technology, and such model can also be adopted by the other institutions, which can then pave the way for the use of AI in the non-peaceful domain of nuclear? Thank you.
Short answer, I hope so. But even in the peaceful uses, this is a sovereign right of a country to use the guidance which are proposed or standards by AI or not. Because those standards which are developed in the field of nuclear safety, nuclear security, or other areas, they are recommended to use by the governments. Governments should integrate them into into domestic legislation. My point that it's not so easier, or the path is not so short from a standard to implementation of that standard in a particular country. But as it was discussed during previous couple of sessions, there are a number of new technologies applications which could create risks for all of us, for all of our countries. So I hope that politicians will be reasonable enough to accept some restrictions, to negotiate those restrictions, and implement them into domestic legislation. But here, IAEA should not be a platform. I don't see any role, to be frank, for IAEA here. Probably we should think about other international organizations, United Nations, first of all, UN Office for Disarmament Affairs, which could play a leading role to negotiate some agreements or regulations in this particular field.
Yes, Sir Khalid, if you have any questions. Mr. Anton, this would be the last question for your session.
A quick question from me, Olamide Samuel, from the Open Nuclear Network. So you raised something very interesting, your last slide, about the increasing energy demand from AI processing. And you talked about how Microsoft, Google, Amazon, Meta are all investing in nuclear energy. Now, many of these companies want to invest in SMRs in Africa. So how is this going to interact with proliferation pressures, given the security concerns on the continent? Thank you.
Well, I personally, being a nuclear physicist by training, I don't have any issues with SMRs. If they are safe, if they are proven, if there is a prototype which was tested and operated, probably the kind of disadvantage which most of SMRs will have to compare with light water reactors, which we know, big reactors, they will use, most of them will use uranium enriched up to 20%, not up to 5%. But still, this is not the level of enrichment which could be used for nuclear weapon. Most of the countries which are interested in the operation of SMRs, they don't have infrastructure to extract this uranium, enrich it further. So I don't see, I would say, additional risks from SMRs if they're under IAEA safeguards control, if they're safe, if their design is proven, and of course, if personnel which will operate them train well enough. And my understanding that many so-called newcomer states, those states which do not possess nuclear power plants nowadays, indicate their interest to build SMRs. And this is fine with me, because also it will be less costly for them to build SMRs than a big reactor. But what is important, their personnel should be well trained. And here, I would not exclude that sometimes, even in the case of big nuclear power plants, like for example in UAE, foreign personnel could assist in operation, at least for a certain period of time. So yeah, for me, the region where SMRs will be used, not so much important, but important the technology, whether it is proven, and personnel, and of course, what role IAEA will play to safeguard this particular facility.
Yes, Mr. Khalid.
Thank you. My name is Khalid Banouri. Good to see you, Antoine. My question, a naive question, if I may, is that do you foresee a problem of standardization of the tools, various tools, that AI tools that will be developed for contributing to the use of peaceful uses of technology, like running the power plant? Is there an issue? Is this even an issue of standardization of various tools that exist? Would the IAEA guidelines actually determine that or help that, or can this become a problem in the future? Thank you.
No, I do believe this is an important issue to standardize the technologies which are used. And again, IAEA should be an appropriate platform to discuss that. And it will require bringing both nuclear experts, operators, and experts in AI. Because also, I mean, there are not many experts globally nowadays who have practical experience to use AI at the nuclear facilities, which means that this kind of mutual enrichment, with expertise of operation of facilities, nuclear power plants where AI was integrated, I think would be quite useful, and both to share benefits and some negative aspects of that, some risks associated with that. So yeah, I do think that standardization could be useful, especially at probably a slightly later change, because nowadays this technology is just being integrated. There is some experience, but not much. Probably we should wait and see, not to kind of update this standardization list quite often. But I think this is really important to keep it in mind. And also, as we are trying to standardize many other issues related to nuclear industry and nuclear power plants. And thank you so much, Dr. Bonnery, for your question.
Thank you, Dr. Anton. Now I request Executive Director Ambassador Nekwi to present a shield to Dr. Anton. Thank you. Ladies and gentlemen, we will proceed with the session. Now I would like to invite our second speaker, Dr. Robert B. Hayes, to share his remarks on the role of emerging technologies in the achievements of UN SDGs. Dr. Robert Hayes is an associate professor in the Department of Nuclear Engineering at North Carolina State University and holds a joint faculty appointment with the Savannah River National Laboratory. He is also a member of the U.S. Department of Energy's Advisory Committee for Nuclear Security, where he advises on issues related to non-proliferation, counter-proliferation, and nuclear emergency response. A certified health physicist and licensed professional engineer, Dr. Hayes has over 25 years of experience in nuclear safety, radiological risk assessment, and technical support for the national security operations. Dr. Hayes is a fellow of both the Health Physics Society and the American Physical Society, with more than 95 peer-reviewed journal publications and extensive services in national and international scientific communities. Over to you, Dr. Hayes.
Can I get my presentation up? All right, now let's have some fun, shall we? So it'll be a lot more fun to learn than to hear my pedigree. So what I'm going to talk about is how small modular reactors can meet the United Nations Sustainable Development Goals in a large way. Something that's not often talked about is uranium extraction from seawater. There's about 4.5 billion tons in the ocean right now, and it's there from runoff, and it's being continually replenished by plate tectonics. So for all intents and purposes, it's renewable, should we choose to extract it from that source. If we were to use breeder reactors, the amount of water, the uranium that's being dumped in the ocean from rivers every year, it's about 9 times the electrical energy needs of the United States. Every year, dumped into the ocean, plating out on the bottom. If we were to extract it, it's a big no, never mind. But there are a lot of other things that nuclear can do. One of the things that's striking, and we're going to get into why this is the case, that if you fold in the statistics from Chernobyl into nuclear energy statistics, it's still safer than wind. It's still safer than wind, even with Chernobyl factored in. And I would argue that's like comparing the Hindenburg to modern air travel. It's a defunct technology that's not even used. Now, part of the reason why comes down to energy density. Now, the previous speaker talked about this. Well, let me give you some numbers to that. If I do combustion of fossil fuels, you get about 1 electron volt per atom that's taking place in that reaction. 1 electron volt. If I fission uranium-235, I get 200 million electron volts per atom. Now, energy density is basically directly proportional to environmental friendliness. And we'll see how that's realized. If you have high energy density, that's why we like fusion, high energy density. It makes it environmentally friendly. Now, with that, you get these fission products. Fission products are interesting little things. It'd be nice if we could turn those into commercial products. That'd be fantastic, and sometimes we do when we have nuclear medicine. But not all of them have a commercial utility yet, but I think that just requires some more research and development. Now, one of the things that really scares people about small modular reactors or any other reactor is used nuclear fuel. Let me contextualize what energy density buys you, even though it's got those nasty fission products in it, and even transuranics. The United States has been using electricity from nuclear for about 50 years, 20%. The biggest economy on the planet, 20% of their electricity for 50 years. That's a lot of electricity. That's a lot. That's a lot for 50 years, 20%. And all of the used nuclear fuel from all of that energy would not fill up a single football field above 10 meters high. Energy density is amazing. There's just so little problems that you get from it, even though they sound scary and huge, but they're not. We have the technology, we know how to deal with it, but there are narratives out there that would counter that. One of the things people are also concerned with is terrorism of used nuclear fuel. This is what is required to get a license from the Nuclear Regulatory Commission to put used nuclear fuel in one of these. You take your design, you drop it 30 feet, it's like 10 meters, 30 feet onto an unyielding surface, wham, it can't leak. You take that same cask, and you've got to drop it 40 feet, or 40 inches onto a steel bar, onto its weakest point, wham, it can't leak. And now I've got to put it into equivalently a tunnel fire, almost 1,500 degrees Fahrenheit, and it can't leak. And then I've got to submerge it in water for 8 hours, 50 feet, and it can't leak. The same cask has to sequentially go through every one of those, and if it doesn't leak, then you can get a license to build it. Now, as a health physicist, radiation safety expert, nuclear engineer, nuclear scientist, I would so much rather a terrorist roll one of these down the road from explosives than to use this on a building where people are. I mean, it may sound horrible, but I would much rather scare people than kill them. And these things are virtually indestructible. So it's like, to me, it's like, well, you know, if this can distract a terrorist, whew, let's distract them. Let's keep them away from the buildings. Have them do something that they probably can't do anything with other than scare people with their bombs. So one of the other ones, the Sustainable Development Goal number 3, medical isotopes. We literally save millions of lives by taking radioactivity generated in the core of a nuclear reactor and sticking it into somebody's veins. Literally, because we can do diagnostics and we can do treatment with that because we know how to control it. It comes down to control. You take something that can be dangerous and you control it and you use it for good. Kind of makes sense. Sounds good to me. One of the things that we can also do is food preservation. In almost every developing country, they grow enough food, but if you don't have energy, how do you preserve it? If you can't cook it, if you can't freeze it, if you can't transport it, what happens to it? Well, it doesn't last. You need energy. Energy provides everything that you can need, everything that you have to have in order to have a high standard of living. It requires energy use. And when you have something that has high energy density, it's a great way to go. All right, radiation risk. That's really what it's all about. It's fear of radiation. That's really what all the anti-nuclear narratives are about. Fear of radiation in some form or another. It comes back to radiation exposure. It's somehow always that, radiation exposure. So let's contextualize it. 0.01 millisieverts. So if I told you that being in this building today, it's going to expose you to 10 to the minus 5 joules per kilogram of radiation dose. Now, it might not scare you, unless you thought maybe that was from making electricity. That would scare people. But if you found out it's from the radon in the air, the natural radon in the ground beneath you, it's like not a big deal anymore. Coming from outer space, the stuff that you just have to have because you're alive. Internal potassium, then it's not going to scare you anymore. It's the same number, 10 to the minus 5 joules per kilogram. It's gobbledygook until you put it in context. That's about what you get, at least in the United States, every day. 0.01 millisieverts. That's about a daily background dose. So that's a real important number. We're going to come back to that because that's very poignant. The question is, does that scare you? Now, after what I just said, the answer is no. But if I hadn't said that, would it have scared you? How do you know? You're not a health physicist. You're not a nuclear scientist. How do you know what that is, right? Maybe some of you are, and you still might have been scared because you didn't know, right? You got to know. All right, 0.05 millisieverts. So if I went from LA to New York and back, it's about what I get. 0.05 millisieverts. That's about the dose I get just from cosmic rays. In the United States, that's the drinking water standard. That tells you how much radioactivity you can have in your water legally. You can have as much radioactivity. So if you drink that water all year, you can't get more than 0.05 millisieverts. That's the regulatory limit. Now, if I told you you got that dose from going coast to coast, you're not going to care. But if I told you, oh, you got that dose because we violated the regulatory standard and you got 0.051 millisieverts, that's scary. You violated the law and gave me an overdose of radiation. Panic ensues, right? That's how conservative we are with our regulatory limits and what we can control, and we do it consistently. We control water to that level. That's the dose, drinking only that water all year. We're going to go up orders of magnitude here. This is a logarithmic scale. This is going to get big soon, but right now we're still talking about regulatory limits and things that scare people. 0.1 millisieverts, that's the airborne off-site release. So if you found out the nuclear power plant gave you 0.11 millisieverts, they broke the law and released too much radioactivity. How terrifying is that? That's the minimum dose that you have to have from internal potassium. How many people knew potassium is radioactive? Oh, a few of you, that's good. How many of you knew that a potassium is essential to life? Even more, excellent. Yes, you die without that stuff, and it's radioactive. And if you're a small, petite female or a child, that's about the minimum dose you get, 0.1 millisieverts. If you're a large muscular male, the potassium goes in the cells. You need more potassium in the cells and more sodium outside the cells. If you're a large muscular male, it's about 0.4 millisieverts. Is that scary? That's being a healthy, muscular man, getting that kind of a dose from internal radioactivity. Is it scary yet? We're going to keep going up, orders of magnitude. What's scary? Let's go up another. Whoops, went too much. 1 millisievert. So if any of you ever have had a dislocated hip, you've had an x-ray of your hip. And that's about 1 millisievert. 1 millisievert is what you can get legally in the United States from a nuclear facility, and that's at the fence. So if I have a nuclear power plant and I have a fence, a homeless person or a cowboy can go set up a tent and live there, and by law, they can't get more than 1 millisievert, or you broke the law. And as a general rule, you're not going to come close to that because the fines are like $10,000 a day or something. So you never even approach the law because it's just too painful to violate that regulatory limit. So now we've gone up many orders of magnitude already. Is it scary? 1 millisievert. That's what you can get at the boundary. All right. So in the US, the average annual is about 3.2 millisieverts. Is that scary? That's what you get, and this is just population average. So this is taking credit for the fact that on the coast, where most of the people are, the dose rates are lower. It's a lot higher on the Colorado Plateau. You see where all that uranium and excess cosmic ray radiation is, 3.2 millisieverts. So you get a lot more variation than that potentially, depending on where you're at, just from natural sources. That's an annual dose. To remember, is this scary yet? Have we got scary yet? Let's keep going, man. We're going to go, we got still many orders of magnitude to go. 10 millisieverts. So if you're gray like me, you've probably had a stress test. They took radioactive thallium, stuck it in my vein, maybe walk a treadmill, and they checked my heart. That cost about 10 millisieverts. In the US, at 10 millisieverts, the EPA can issue evacuation orders if a member of the public can get 10 millisieverts in a year. And if they can get the 5
millisieverts every year after that, basically right near natural background, they can maintain evacuation orders permanently, tell you to move from your house. Now the cognitive dissonance seriously has to set in. You're being told to permanently move from your house for a dose that you could get from a CT scan to the head, chest, or hip. I've had those. Who's had a CT scan? That's about 10 millisieverts. That's about what it could cost you to have to move from your home. Now, usually it'll be more like 20, but that's the minimum in the U.S. that you have to, a member of the public has to have before you can be asked to permanently move from your home. That's cognitive dissonance. Have a health physicist say, it's not that big of a dose. Why are you telling me to move? Right? That propagates narratives in society. This stuff, how do you trust these people? They're nuclear scientists that don't know what they're talking about. But we do. We just understand that we're incredibly conservative. 50 millisieverts. In the US, that's a legal dose to a radiation worker. Is it scary yet? This is considered, we're using what's called a linear no threshold. Assuming that's true, this is still a safe dose. The risk that you would get from this is still small compared to industrial risks. Is it scary yet? Nice. All right, let's go up to the full 100 millisieverts. There have been a couple journal papers, and that's it, that have suggested that there is evidence that shows for children undergoing radiotherapy that you can get an increase in cancer probability of 0.5%. It's the first indication of any measurable medical effects from radiation. We've just hit it. We've just now hit measurable medical effects. Nothing else has ever been shown to have any measurable medical effect at all. Not a scratch, not a sneeze, nothing. Nothing you can discriminate from natural occurrences. Now, in the US, if you live long enough, your cancer probability is about 40%. You live long enough, half of us are gonna get something. If you're pasty white like me, it's probably melanoma, who knows, whatever. But the point is that we finally hit that threshold at 0.5%. Now, by the time you get up to 1,000 millisieverts, a sievert, now you're just at the threshold for acute radiation syndrome, and yes, now you have that 5% increase in cancer probability. This is like atomic bomb survivors. This is a big dose. So from 40% to 45%, big old dose, you just hit acute radiation syndrome. So you're still not gonna die, but you do have an increased cancer risk. Now we go up to 5,000 millisieverts. Well, that's a big dose. That's called a lethal dose. Now we say it's a lethal dose, but we interpret it, because it doesn't mean you're gonna die. It means if you don't get medical attention at this kind of a dose, half the people will die within a month from acute radiation syndrome. Your immune system is gonna tank, boom, within 2 weeks. You need to be in a hospital to get antibiotics, antivirals, antifungals, because you just tanked out your red bone marrow. It's not gonna be able to produce those white blood cells and the natural killer cells and everything else. Your blood system is just gonna get whacked. The stem cells in your red bone marrow just got a big enough dose to compromise them, and your body has to recover. All right, 10,000 millisieverts. Yeah, now you're in hospice. Now you're in hospice. So the point is, what's scary? So people are terrified, I kid you not, and we'll see that top one, 0.01 millisieverts can cause visceral terror. And yet everything in the top has never been shown to have a measurable medical effect. And so now I ask you, if something doesn't have a measurable medical effect, how much fear, how much time, how much money is that worth? Apparently the United States is worth billions. We'll spend billions to prevent those kinds of doses. And that tends to be the shared narrative around the world. That's how much it's worth to prevent those kinds of doses. Billions. I can give you many examples where we spent billions to prevent doses upwards of about 0.1 millisieverts. It terrifies people. And they vote for people that are also terrified. It's the nature of things. What about nuclear accidents, right? That's one of the big ones. People will use one of these. If they want to be opposed to nuclear energy, they'll say 3 Mile Island, or they'll say Fukushima, or they'll say Chernobyl. That's like to them, that's a conclusive statement. Well, let's contextualize that. 3 Mile Island. The reason why I had that dose right up here, 0.01 millisievert, why I picked that and picked something a lot lower, is because that's the average dose, that 0.01 millisievert, that's the average dose to a public resident from 3 Mile Island. That's why I started there. And that terrifies people. An average dose that's about what you get in a day, they got over a week. It terrifies people. That terrifies people. All right, well, what about Fukushima? That's not this Chernobyl thing that's no longer there, that everybody had agreed, at least in the West, we agreed it was a bad design to start off with. And then it was operated horribly and they had no emergency response. Would have been easy to fix any one of those, at least in our opinion. 3 Mile Island, that's a Western design. Not 3 Mile, I'm sorry, Fukushima, that's a Western design. If you look at the United Nations report, the World Health Organization report, any of the review papers that have looked at the health consequences, Fukushima is not expected to produce any expected measurable medical effects in the Japanese people ever, ever, ever. Typical doses were below that threshold by almost an order of magnitude, less than 1,000 millisieverts, less than what you got for a CT scan. That's what they got. That's way below anything. So they realized the only people that died from Fukushima were in a panicked evacuation. So this contextualizes it right there. People risked and lost their lives to avoid something that would have no measurable medical effects. That's why I ask, how much fear, how much time, how much money is that worth? Because apparently it's worth a lot in our society. Now let's talk about Chernobyl. Now let's talk about visceral fear. Chernobyl, that did produce measurable medical effects. We got big doses from people. This study down here, Rehu and Rehu, this is crazy. This is just fanatically crazy. When the former Soviet Union responded to Chernobyl, Estonia was part of that, and so the members of the military who were from Estonia and responded provided an amazing cohort. There wasn't a whole lot of fallout there. And so you had men from Estonia, had the same lifestyle, ate the same food, did the same stuff, that responded to Chernobyl, and a lot of men that didn't. They were not in the military at the time, so you could compare those that responded, the liquidators from Estonia, to those that weren't. And this study showed a small, statistically significant increase in cancer. Who's surprised at that? Not so much, but what they found is that when they trended these people through the years, there was a massive increase in suicides for liquidators. And it came back to the same paradigm, right? 10 to the minus 5 joules per kilogram. You got that from Chernobyl. Are you going to be afraid? Probably, right? 0.01 millisieverts. Oh, what is a 0.01 millisievert? I don't know what that is, right? Maybe everybody now you have, but would you have been afraid of that before this talk if you found out you got 0.01 millisieverts from Chernobyl? They were. And any kind of deleterious health effect that they had, arthritis, loss of memory, loss of hearing, going bald, whatever, must have been Chernobyl. How do you know it wasn't? How do you know it wasn't Chernobyl? And so it just becomes a self-fulfilling prophecy. Anytime something bad happens, it proves you have no hope. Look, it just happened. I just had a health effect. Must have been Chernobyl. How do you know? Are you a health physicist? Do you know what it causes? I know, right? That's the average person. And so it's terrifying. Oh, am I supposed to get done? All right, well, bottom line is when you have this high energy density, you can start hitting those sustainable development goals just one after another. It just meets them. In terms of affordable and clean energy, pretty good. In terms of environmental impact, how many materials do you have to dig up? Mining, milling, manufacturing, waste generation. If you look at it, if you don't look at the fuel, you just look at what it takes to make the plant, nuclear is fantastically better than solar and wind. It just doesn't take a lot of materials. Unless you like mines, milling, tails, factories. What about land use? We already did this. Here's some numbers. You can see orders of magnitude. This is logarithmic. Nuclear just takes a tiny little footprint, tiny little footprint. If we use nuclear, you could do desalination. You could make concrete, steel, hydrogen, industrial heat, all of those things that right now we burn fossil fuels for. You do that with nuclear. Imagine if we also did water extraction, or uranium extraction from the ocean. I had mentioned for the food preservation, right? Think of all the cesium that we're throwing away. I can go and sterilize food, pretty easy. That's pretty cheap stuff. And you could sterilize it, give it a huge shelf life. You just not got to be afraid of irradiated food. Just heating it up. Greenhouse gases, and then I guess I can end there, going through it really fast. You basically hit the important ones, I would argue. If you want sustainable development, nuclear is the way to go. Energy density. Fusion, right now it's a fairy tale that might come about in 50 years. If ITER works, if the ITER works, it's still just an experiment. It's not going to produce a single electron of electricity. That's if it works. Then you still got to boil water with it. And so who knows how long that'll be. This we can do now. We can't do fusion now, but we can do fission now. I'd say that's good enough. Hopefully that was fun. Questions? Oh, we're not doing questions. Sorry.
Thank you, Dr. Robert Hayes, for your valuable insight on this important matter. And you rightly said that the UN SDGs provide a global framework for the peace and prosperity and the environmental protection. And with the help of AI, with the help of the emerging technologies such as AI, the states can easily achieve these SDGs, which is crucial for humanity. Now we move forward to our third and the last speaker, Dr. Tariq Rawouf. I would request him to share his views on the emerging technologies for the nuclear safety, security, verification, challenges, and opportunities. Dr. Rawouf is currently an independent expert on nuclear governance based in Vienna. He's expert trainer on disarmament and arms control at the United Nations Institute for Training and Research, UNITAR, as well as International School on Disarmament and Research on Conflicts, ISODARCO. Dr. Rawouf has worked as IAEA liaison and point of contact for Nuclear Supplies Group, Committee for the United Nations Security Council Resolution 1540, and Counter-Terrorism Implementation Task Force. He coordinated IAEA multilateral approaches to nuclear fuel cycles and also responsible for the IAEA Forum on Experience of Nuclear Weapons Free Zone relevant for the Middle East. Within IAEA, Dr. Rawouf was reporting to Director General. He also remained Director Arms Control and Disarmament Program at Stockholm International Peace Research Institute, SIPRI, as well as Director at International Organization and Non-Proliferation and Center for Non-Proliferation Studies, Monetary. Over to you, Dr. Tariq Rawouf.
Thank you very much, and I would like to start by thanking Ambassador Ali Sarwar Naqvi and his competent team at the CISS for organizing this very capable and competent conference, which is very interesting. I recall that when I first joined the IAEA, Ambassador Naqvi was the permanent representative of Pakistan to the International Atomic Energy Agency, as well as to other UN organizations in Vienna, and also the ambassador to Austria and neighboring countries as well. And I was very grateful to the hospitality and friendship that he extended to me at the time when I first arrived in Vienna. So my comments are based primarily on documentation from the International Atomic Energy Agency, as well as other related documents, but the views that I express are solely my own. Artificial intelligence at its core is machine learning that holds promising potential for utilization in various aspects of the nuclear fuel cycle. I just lost my screen, so I'm trying to get it back. Okay. In various parts of the nuclear fuel cycle, that's nuclear verification, nuclear safety, and nuclear security. Machine learning, including large language models, internal operations in general, are incomprehensible to humans. As the ML system operates, vast arrays of numbers change as the system learns and processes data. All knowledge in the ML system is in this set of numbers, which means that it is hard to derive or understand the rules that drive it. AI proponents consider machine learning by computer systems as mimicking human logic in problem solving and decision making. AI relies on transformers that are a type of neural network architecture that transforms or changes an input sequence into an output sequence. They do this by learning context and tracking relationships between sequence components. For example, consider this input sequence. What is the color of the sky? The transformer model uses an internal mathematical representation that identifies the relevancy and relationship between the words color, sky, and blue, based on the training data fed into the system by human operators. It uses that knowledge to generate the output, the sky is blue. AI ML skeptics argue that the human brain contains more than 100 trillion transformers and all the computing capability in the world is unable to match it. In any case, artificial intelligence and machine learning is dependent on human-generated training data and operational algorithms. Furthermore, machine learning or artificial intelligence does not enable violation of the laws of nature. AI or ML cannot create facts where none existed previously. Insights regarding known facts is not creation of new facts, and it cannot address unknown unknowns any better than humans could. But artificial intelligence could enhance understanding of known phenomena within limits. Even quantum computing suffers from these weaknesses and limitations, according to the Alan Turing Institute at the Royal Institution in London. At its core, then, machine learning is statistics. As such, correlation is not causation. Garbage in, garbage out still holds, and bad or biased data shall yield bad or biased outputs. Thus, over time, bad or biased data will be learned and propagated with corrupted solutions. This applies particularly to large language models, which rely on training data mined from the data in the World Wide Web, globally about 500 billion words, which, as we know, contain both good and bad or biased data. By the way, you too could download all 500 billion words from Common Crawl if you have a very large data drive and your internet connection is not throttled. As such, there should be serious concerns about the training data fed into AI, machine learning, and large language model systems, especially concerning nuclear safeguards, safety, and security, the three S's. Why do I say this? Because the training data on these matters inherently is based on value judgments of Western sources, for now primarily US, and government, industry, academia, media, and related policy forums. Such data can be deeply biased as states in the Global South, broadly defined, are considered as proliferation threats and challenges to the nuclear order established by Western technology holders. Open source information providers for this enterprise include research and educational institutes, such as Project Alpha and others, media sources such as the Economist Intelligence Unit, Janes, Google, CIA Factbook, and similar entities, in addition to intelligence organizations. Now, the experts in collecting and analyzing such open source information in many, though not all cases, do not have subject or nuclear technical or language expertise, but have access to powerful tools to manage big data using platforms such as Palantir, Oracle, Google, Meta, and Amazon, as well as open source satellite imagery from providers such as Airbus, Maxar, Planet Labs, and others. This OSI is then fed into AI and machine learning proliferation trackers, and the results form an integral part of the state nuclear profile. Such collection and assessment measures are applied in a differential manner, and to the best of my knowledge, are not carried out to a similar extent, for example, for countries such as India and Israel, and even if so, not with the same rigor. On the other hand, so-called proliferation risk states could include, for example, Algeria, Egypt, Morocco, Saudi Arabia, Turkey, among others. However, friendly proliferation cases such as Japan, Poland, Germany, South Korea, and others do not merit similar deep scrutiny. So the conclusion here is that on 3S nuclear matters, there are serious concerns about bad and biased trading data fed into AI and ML systems with attendant consequences. Generative AI, a subset of neural networks deep learning, has captivated the public's attention by crafting original texts, images, and videos. It is highly versatile and could be adapted to many different functions or activities. You have it on your mobile devices in the form of predictive text, Google Translate, ChatGPT, DeepSeek, and other related apps, and we all know that they often are riddled with errors. While generative AI could help with administrative tasks as in other industries, its use in operating nuclear facilities and power plants is problematic due to deficiencies in its integrity and overall opacity. It is not yet entirely understood how artificial networks function and come to conclusions. More transparent systems called explainable generative AI possibly could hold promise for broader use in repetitive tasks and data processing in the civilian nuclear fuel cycle. Now coming to artificial intelligence, machine learning versus advanced robotics in the nuclear field. There's a tendency sometimes to equate artificial intelligence and machine learning with advanced robotics, but there are important differences. Many advanced robots are achievements of biomechanics aided by computer code through innovative programming of algorithms to perform repetitive motion tasks. Advanced robotics, therefore, based on biomechanics, refer to sophisticated machines designed to perform complex physical tasks, acting in the physical world, relying on hardware, sensors, actuators, and mechanics, again, based on programming or training data. So when AI and machine learning is combined with robotics, the result is intelligent robots, which are machines that in certain cases can respond to their environment and make programmed decisions, such as, for example, aviation autopilot technology, autonomous drones, or self-driving cars. So the utilization of intelligent or intelligentized robots in the nuclear fuel cycle include nuclear fuel loading and unloading machines, robotized Surenkov viewing device, that is a floating robotic device on spent fuel ponds to measure the Surenkov glow to count submerged cooling fuel assemblies. Laser curtain for containment and tracking. And this has already been installed at facilities at La Hague in France, Atusha in Argentina, and Onkalo in Finland. In Iran, online enrichment monitors have been deployed at the Natanz and Fordo enrichment plants. And lastly, in this particular example, suicide robots to enter nuclear accident sites such as damaged Chernobyl Unit 4 and the Fukushima reactors to determine the state of corium radioactivity and to plan for remedial engineering solutions. Now moving on to machine learning applications. Notwithstanding the concerns just cited, machine learning and robotics have been applied in the nuclear industry for some time and have proven useful in various areas. Operators leverage machine learning algorithms for real-time monitoring and predictive maintenance. The software efficiently identifies anomalies by sifting through copious sensor data, allowing human analysts to focus on potential irregularities. The operator only looks at pertinent data instead of searching for the needle in the haystack. We remove the haystack. This is according to a nuclear operator. Such confidence, however, belies data gaps and bad data and could result in system failure when crucial interactions or connections may be missed or misconstrued by the AI system. The human in the loop cannot be dispensed with. AI's potential applications for nuclear power plants could, for example, bolster efficiency and ensure a steady electricity supply by adjusting power generation based on real-time data such as consumer demand, weather, and equipment performance. Artificial intelligence, machine learning, and robotics technology do not replace human analysis and intervention, though such technology could deliver faster, more accurate results while relying on less yet indispensable human interaction. While there is tremendous interest in AI solutions in the nuclear industry, but before any new technology could be deployed on a large scale in nuclear power plants, regulators need to know and understand applicable AI and ML technologies thoroughly to develop guidelines and issue licenses and permits for their use. For the future deployment of this technology, it is crucial to develop regulatory frameworks in collaboration with the regulators and industry. The International Atomic Energy Agency has supported AI's potential application in operations of nuclear power plants since 2021, producing a report on power plants that focus on the regulatory and technical aspects of AI deployment. The IAEA has designated the Center for Science of Information at Purdue University in the United States as an IAEA collaborating center to support the agency's activities on artificial intelligence for nuclear power applications including reactor design, plant operations, and training and education. I see that in the audience there is Dr. Pervez Ansar, former chair of the Pakistan Atomic Energy Commission, former chairman of the IAEA Board of Governors, who is very familiar with Purdue University because that's where he got his training. So I think he would be quite pleased that the IAEA is collaborating with his old university. The agency also has designated the Massachusetts Institute of Technology Plasma Science and Fusion Center as a collaborating center on accelerating fusion research with an emphasis on AI applications to advance the IAEA's AI for Fusion initiative. So in all, there are now 73 IAEA collaborating centers worldwide. The IAEA also is leading a coordinated research project to explore how AI and innovative technology could help to expedite the deployment of small modular reactors. The IAEA will host the first ever international symposium on artificial intelligence and nuclear energy at its headquarters in Vienna this year from the 3rd to the 4th of December. This symposium will explore how nuclear energy can help meet growing electricity demand from the data centers driving AI, as well as the myriad ways AI can support the nuclear power industry. With AI's rise mirroring nuclear power's recent and ongoing revival, this event is especially timely and will highlight the emerging nexus between the two key industries and focus on the dual themes of powering data centers with nuclear energy and opportunities and challenges for AI in the nuclear sector. Now moving on to leveraging artificial intelligence for enhanced nuclear verification by the IAEA. AI/ML has several uses for nuclear verification by the IAEA in implementation of the agency's safeguard system. It should be noted that regardless of the type of safeguards agreement, the agency applies the same safeguards objectives and safeguards measures to specific types of sensitive nuclear technology and facilities, as well as to nuclear power plants. The details are beyond the scope of this discussion, but interested parties could look up my presentation on the matter to the Conference on Disarmament. It is document Proceedings Verbal PV 1037. The objective here is to reinforce the effectiveness, efficiency, and credibility of IAEA safeguards through the integration of advanced technologies and improved data analytics. For purposes of this discussion, here are some non-exhaustive possible focus areas for AI utilization for safeguards. 1. Satellite imagery analysis for detection of undeclared nuclear activities. This offers near real-time detection of suspicious changes, for example, construction of fuel fabrication, enrichment, and reprocessing facilities, nuclear reactor activity, mining, storage, and disposition of spent nuclear fuel, as well as for planning inspector visits. Image and video analysis. Identifying surveillance footage. AI can help analyze thousands of hours of CCTV footage from nuclear facilities to detect unusual patterns, unauthorized access, or tampering with equipment. Next, integration of emerging technologies. Internet of Things sensors, IoT sensors, deployment of tamper-proof sensors to monitor in real-time storage conditions, movement of materials, and facility operations. And blockchain for data integrity, for secure, auditable logs of verification data to prevent tampering and increase transparency. There are also uses in expanded environmental sampling and forensics. This would enhance laboratory capabilities to detect isotopic signatures in air, water, and soil that may indicate undeclared nuclear activity, and also to miniaturize and deploy field-portable detectors for in-situ containment and surveillance. There are also AI uses for modernization of inspection protocols, to develop optimized inspection protocols and timelines criteria as significant quantities of nuclear material under safeguards increase, and also to increase the use of unattended monitoring systems to reduce the resource burden. Lastly, predictive maintenance and equipment monitoring. AI could help monitor the health of installed safeguards instruments such as cameras, seals, radiation detectors, etc., and predict failures before they occur, ensuring continuous verification operations. Now moving on to leveraging artificial intelligence for enhanced nuclear safety and nuclear security by the IAEA. Nuclear safety and security are central to the IAEA's mission of safeguarding the safe and secure peaceful uses of nuclear energy. As emerging threats evolve in sophistication, ranging from cyber attacks to insider threats, so too must the tools used to prevent, detect, and respond to them. The objectives for AI deployment here would be to strengthen the IAEA's capacity to, one, detect unauthorized activities and threats in real time. Second, to analyze complex data for early warning and response. And third, to enhance physical and cyber safety and security at nuclear facilities. The following are some possible uses of integration of AI intelligence technologies into nuclear safety and security operations, policy, and monitoring mechanisms. So the potential tools to be deployed could be anomaly detection in SCADA systems, AI-enhanced intrusion detection and prevention systems, and predictive threat modeling from global cyber intelligence feeds. So with regard to cybersecurity, AI could help protect digital infrastructure controlling nuclear equipment and facilities by intrusion detecting anomalies in network traffic, enhancing vulnerability scanning and automated patch management, and predictive threat intelligence using machine learning on cyber attack patterns. There are also uses for physical protection systems to enhance automated perimeter surveillance, for example, drones and smart fencing, integrate multiple sensor systems, thermal, acoustic, visual, and pressure, for 360-degree situational awareness, and update nuclear safety and security design-basis threats, response protocols, and cyber nuclear hybrid threat models with AI-informed analysis. And lastly, in this category, emergency response optimization. AI simulations could model emergency scenarios and recommend optimal evacuation routes or containment actions. AI could dynamically update crisis response plans based on new data, weather, radiation spread, infrastructure, etc., and enhance communications and decision-making during incidents and events with AI-assisted dashboards. So what are our conclusions? Integrating AI and machine learning into the IAEA's nuclear 3S frameworks offers possibilities of a transformative opportunity to stay ahead of evolving threats and challenges, but at the same time, there also are significant risks to the integrity of the agency's operations. With appropriate safeguards, transparency, and collaboration, AI and ML could only be an enabler, but it has the potential as a force multiplier in the IAEA-led global effort for enhancing safety and security of nuclear materials and infrastructure. However, on its own, artificial intelligence and machine learning cannot engage in credible nuclear governance, and there is no substitute to maintaining at all times competent human oversight in all critical operational and decision-making processes. Integration of AI and ML technology into the nuclear fuel cycle sector comes with significant risks because, one, deepfakes can spoof a wide variety of data. Two, such technology as well as hacking tools are becoming cheap and accessible. Three, state and non-state actors and criminals already have used this technology to infiltrate and disrupt critical nuclear infrastructure operations. And lastly, false positives and misinterpretation of ambiguous events could damage the integrity and credibility of nuclear governance measures. So what could we recommend? It could be useful if the IAEA, together with representatives of the AI, machine learning, and nuclear power sectors, jointly develop what is termed as risk-informed and performance-based regulatory frameworks for utilization of artificial intelligence and machine learning technologies in the areas of nuclear verification, safety, and security. Finally, IAEA member states continue to remain divided over the benefits of AI/ML technologies and the wide scope of the agency's work. While some urge greater utilization of such technologies, others caution that widespread integration of these technologies into the IAEA's work in nuclear safeguards, safety, and security remains controversial and with significant risks, and thus could adversely impact on the agency's independence, technical integrity, and credibility. So thank you very much, and I would be happy to take questions.
Thank you, Dr. Tariq Rauf, for sharing your valuable insight. And you rightly mentioned that the regulatory frameworks for utilizing the emerging technologies needs to be developed. With this, the ladies and gentlemen, now I would like to open the floor for the interactive session. Please introduce yourself before asking any question. Kindly keep your questions precise and to the point. Also note that each person should ask only one question to accommodate as many participants as possible. Also make sure you direct your question to one speaker or if wish to several speakers. We are going to take a set of 3 to 4 questions due to the time constraints. Thank you.
Okay. Good afternoon. My name is Anna Murad Khan, and I am a research assistant at Center for International Strategic Studies, Islamabad. My question is directed at Robert Hayes. First, I would like to compliment that kudos. You have brilliantly dismantled the myths surrounding nuclear energy. And yeah, you didn't disappoint me this time. So the question is that, what do you think are the factors contributing into this negative perception of nuclear energy, besides the horrible nuclear accidents and all that detonation fears and all? I am particularly interested to know the economic dimension, the upfront cost that are adding into the hesitance of third world countries and the developing countries to use nuclear energy as a viable source of energy generation. Thank you.
I can project, so I think you can all hear me if I talk.
Is this going to work? All right. I guess I can talk here. I'd rather not, but I guess I will. All right. The economic damage, 10 millirem per year, right? So that's the EPA limit. In a former lifetime, I worked at the Waste Isolation Pilot Plant, a geological repository for transuranic waste, and they had an event. Los Alamos National Laboratory sent them a drum, which basically exploded. But for all intents and purposes, it was a dirty bomb. And so I did the emergency response, and I was there for the recovery. Now, the release, all the safety systems worked. And so the actual release was about 1% of that. So if it had been controlled and if it had been planned, it would have been within their license, a small fraction of their license. It terrified people, right? You had a drum explode at a geological repository. It terrified people. But the safety systems worked. It worked as designed. It exactly worked as designed, so it was a small fraction of it. But the Department of Energy, in order to get it back to that place where it was not releasing anything, instead of the 10 millirem per year, which they had a license to do, they spent about $2 billion to get that facility so that it was not releasing anymore within its license. It could have kept going within its license, but because it terrified people, the politicians wouldn't stand for it. I remember hearing a politician once say that they know the casks are safe, just not when they're in their state. It's like, what? And the cost of that, right? You could leave it safely in the state, but now if I've got to spend, another $500 million, the primary component of cancer and bacteria, it's got, by definition, the highest pH of 7. Thousands of people die from drowning. And if you've drank it, you will die or you have died. You can make narratives of something that's innocuous. You just spin it. It's not hard to do. And when you tie that with a narrative that by endorsing that position, that makes you a good person. People that have adopted these narratives believe that this helps to justify why they consider themselves a good person, because they oppose nuclear energy. And so it's very difficult to divorce somebody of that. When you've been opposing nuclear energy, and that's part of why you tell yourself you're a good person, it's very difficult to think otherwise, because anything that contradicts that is either cherry-picked, it's biased, it's disingenuous, it's simply not reliable. And so that's very difficult to root out, but that's where we are.
This, I would repeat myself because appreciation isn't enough. This is by far the best set of speakers on peaceful uses of nuclear energy and its nexus with emerging technologies, brilliantly talked about by all these speakers. My question is, I am a strong advocate of small modular reactors, but when it comes to public perceptions, it's a bit difficult to make people understand how a small thing would be safe and secure. So in that sense, if we look at the use of emerging technologies, why can't we use them positively in a way that at least the technical hurdles that the SMRs have, because of which they're not being deployed, why not we using emerging technologies, maybe AI, to speed up the process? Or maybe, I mean, it may be a layman question, but can we use some of these emerging technologies to kind of test the subject, that is the SMRs, and get the designs approved? Thank you.
So AI is great if you've trained it well. I would characterize AI as having the ability to do what a person can do. That's really all an AI can do, is make a decision. And as with a person making a decision, if you randomly pick a person on the planet and say, be in charge of that, you're probably going to get some bad decisions because the person wasn't trained. They didn't know what they were doing. It might be random. But if you pick a really good person that's been really trained really well, that's like AI that's been trained on a great set of data. But it can only really make decisions that's related to the data that it has. And so if you have AI that has that data, then yes, it can help you make those decisions. But the Nuclear Regulatory Commission is going to insist that that data, if it's testing for materials, basically the SMRs, the design is passive walk-away safe. That you can't do a phase change. There's not enough heat in there to cause a phase change if you quit removing the heat. It will just get really hot, and then you'll waste a whole bunch of money. And passive walk away safe like that. You don't want to lose all that money, so you're not just going to walk away, but that's the point. That's the new designs that we have in Gen 4. And so being able to prove that those materials don't have the issues that would compromise that design specification requires actually doing the testing. And so if I had AI that could do that testing prediction for me, I'd have to train it on testing data. And so I have to test that stuff in that configuration in order to have AI make those decisions. And so that requires having irradiated the pebbles, the Trizo pebbles. That requires irradiating the molten salt. That requires doing all the testing for the new materials, for the new configuration, for the new design. And you can use AI today to help guide that, but it's not going to be sufficient for the NRC to say that that's adequate unless I actually have testing data in the AI that basically would nullify the need for AI. That's the level of QA that's going to be required. And so it could help you make your decisions faster if you had great data that would allow you to navigate that. But you've got to have that data to train it so that it can help guide you. Does that answer your question? Okay.
So I wanted to comment on this matter as well on SMRs. So there are somewhere around 80 different designs that are under consideration. Only about 2 or 3 are being worked upon. Nobody has yet commissioned an SMR. And the question here is called FOAC. This is not a rude word, but FOAC stands for first of a kind. And the first of a kind SMR will cost also about $1 billion. It will require more or less the same level of environmental assessment, licensing, and other procedures. So the economics of SMRs still need to be proven. The other big concern about SMRs is the use of high assay low-enriched uranium, HALEU, which can be up to 19.95 or 19.97%. That's just below the threshold of HEU, which is 20%. And from an enrichment perspective, from a verification perspective, this creates new concerns. So we need to really see whether these technologies work out, whether SMRs will generate the cost effectiveness that the proponents of SMRs are propagating. And now there's irrational exuberance by these big data centers, the Amazons, Googles, Palantirs, and others wanting to build SMRs. There's also interest from the shipping industry to have nuclear-powered cargo ships. But again, none of these people are focusing on where the nuclear fuel has come from, how these things will be licensed, what are the different aspects of nuclear safety and security. So one is not dismissing these, but we need a lot more work, and I'm glad that there are people at the CISS who would like to do more research on this. And finally, you can see that I chose an artificially generated background for my presentation today just to lighten the proceedings.
Thank you, Dr. Rao. Yes, Ambassador Naqvi.
It's a pleasure to see you, and thank you for recalling the time when I was in Vienna, and we worked together on many matters. My question is about the capacity of the IAEA in the application of artificial intelligence for nuclear safety, security, and verification. Because, I mean, I have high respect for the professional competence of the people who work in the IAEA, and they have excellent competence for many other areas. But artificial intelligence is something new, and I am just throwing up a thought as to how able or how much capacity the IAEA has for this task. I'd like to know your comments on it.
Thank you, Ambassador Naqvi, and that is a very pertinent and relevant question. The IAEA is facing significant personnel resource challenges across its three areas of verification, safety, and security. But we have experts in machine learning and artificial intelligence who know nothing about nuclear, and we have experts in nuclear who know nothing or very little about artificial intelligence or machine learning. And that is why I had proposed this performance-based criteria to bring the industry, the technology holders, and the IAEA together to work on developing common protocols on how this technology could be deployed. You would know that this is the time when the Planning and Budget Committee of the IAEA is meeting, and there are a couple of lines in there for funding for AI, and there is quite a bit of pushback from member states, particularly from the Global South, about funding for AI, because they're more concerned about the concerns that I raised about the use of AI data for verification and non-proliferation purposes. So there still needs to be much more engagement on this matter between both member states, the industry, the Secretariat, to try to come up with the protocols, frameworks, and regulatory structures that are needed. But you're absolutely right that this is a continuing challenge. And I hope the Pakistan Atomic Energy Commission, the Nuclear Regulatory Agency, and others could contribute to the various coordinated research projects and other activities going on at the IAEA, so that this field is not completely dominated by experts from the global north, so to speak.
Thank you, Dr. Tariq Raouf. I hope we don't have any other question. We can take one last question, or else we are going to conclude the session. Okay. So thank you both of these speakers and dear participants. The emerging technologies such as AI, machine learning are crucial for providing the opportunities for the efficient, safe, and secure nuclear applications. These digital tools are pivotal in enhancing every possible aspect regarding the peaceful uses of nuclear energy, ranging from energy production and healthcare to agriculture and environmental protection. But to fully operationalize these technologies, the countries need to have a regulatory framework. With this note, I hereby conclude the session. Thank you all for your patience and valuable participation. Thank you.
Thank you, Dr. Rahat. It was such an enlightening session. Dear participants, we will now proceed with the shield distribution ceremony. May I request Executive Director, Center for International Strategic Studies, Islamabad, Ambassador Ali Sarwar Naqvi, to come forward and present shields to our worthy guest speakers. So first recipient of the shield will be Dr. Robert Hayes. Dr. Robert Hayes is an associate professor in the Department of Nuclear Engineering in North Carolina University and a joint faculty appointee with the Savannah River National Laboratory. Dr. Hayes, please come forward. Although Dr. Tariq Rauf joined us online and cannot receive his shield in person, we extend our sincere gratitude to him for his thought-provoking reflections on nuclear safety and security. Finally, I request our moderator, Dr. Rahat Iqbal, to please receive her shield. Dr. Rahat is Associate Director, Research at CISS Islamabad. Ladies and gentlemen, as we wrap up the day one of our two-day international conference on nuclear deterrence in the age of emerging technologies, let's make a moment to reflect on today's thought-provoking discussion. We have explored how technological advancements are reshaping deterrence strategies, presenting both challenges and opportunities. The insights shared today reinforce the importance of vigilance, collaboration, and foresight in safeguarding global stability. With the delicate balance between innovation and security remains at the heart of nuclear deterrence, and as custodians of peace, it's on us to stay ahead of emerging risks and adapt wisely. We truly appreciate your participation and look forward to welcoming you all back tomorrow for another impactful day. Thank you all.